So the research we're doing here is that we're trying to identify some of the molecular changes and protein changes associated with osteoarthritis development in mice. One of the leading causes of osteoarthritis is anterior cruciate ligament injury, particularly identified in athletes and individuals with joint injuries. So when you have a ligament that holds the knee joint in place, when the ligament is broken, it causes the joint to destabilize. And when you have a joint destabilization, the cartilage have a tendency of, over a period of time, it gets broken down. So that leads to osteoarthritis development. After ACL injury, an individual develops osteoarthritis between a decade or two after the injury. Usually during diagnosis, let's say for someone that goes to the doctors and say, hey, I'm having limited mobility, my joint's swelling, I'm having pain. By that stage, usually the joint is damaged to a point where short-term recovery is not very possible. So one of the goals that we're trying to do is looking at, using animal models at different stages as a joint is developing arthritis, and we're trying to capture each event during early, developmental, and late stage of OA. So what we're trying to do in our research is depict at different stages what is going on the genetic level and also what's going on at protein level. Using the computational tools, we're hoping to identify specific proteins that are elevated with the progression of the disease, which is very difficult to capture in humans. So that's what we're doing in animal models. The idea is if there is something or a protein particularly that is increase with response to injury that might have a protective role, we want to increase that protein at a local region. The ultimate goal is to have a preventative protein of some sort that can be introduced to the joint, which prevents cartilage from breaking down. So if the cartilage is preserved, ideally an individual's mobility will also be preserved, and it should prolong an individual's quality of life. In my study, our hypothesis was that with response to injury, there is an elevated protein. And we were surprised because other people have suggested in different literature that this protein is only at specific regions of cartilage erosion. In my study, what we found is that this protein is actually elevated throughout the development of the disease, which suggests that this protein is very much necessary with response to injury that may be playing a role in protecting the cartilage over time.